Can people live on another planet? The million-dollar question many people want to know. Exoplanets are potentially an answer to that question. But what are exoplanets? Exoplanets are planets that orbit around other stars in our universe. The study of exoplanets began back in ancient times. Greek astronomers wanted to know if there are worlds other than our own. However, these views were ahead of their time, as they still didn't know a lot about our own solar system. Therefore, the actual search for exoplanets began after Galileo's reinvention of the telescope in 1609. The first documented search wasn't until the late 17th century, by this man, Christian Huygens. And much later, on October 5th, 1995, the first exoplanet was finally discovered. This planet is referred to as 51 Pegasi b. It is 50 light years away from Earth and orbits its host star every 4 days. The closest exoplanet is Proxima Centauri b, found in 2016. It orbits Proxima Centauri, the closest star to our solar system. Since 1995, many more exoplanets have been discovered. As of March 1st, 2020, there are 4,187 exoplanets and 3,105 systems. One theory about exoplanets states that there is one exoplanet for every star in the Milky Way, meaning that there would be over 1 trillion exoplanets. Exoplanets are hard to see directly with telescopes because they are hidden by a bright glare of the stars they orbit. There are 5 methods. The first one is radial velocity. A star that has planets doesn't orbit perfectly around its center. Therefore, from afar, this off-center orbit makes a star look like it's wobbling. Although many planets have been found this way, they have to be bigger than the size of Jupiter. The second method is direct imaging. In this case, the glare of the star is blocked by the planet. The third method is astronometry. This method is the observation of a star in relation to other stars. The fourth method is gravitational microlensing. This method is the observation of the light of a star being bent by a planet's gravitational pull. The final method is transit. In this case, when a planet passes in front of its star, it blocks out a little bit of the star's light. In 2009, NASA launched a spacecraft called Kepler to search for exoplanets. Kepler used the transit method. Astronomers observed how the brightness changed on the stars, which helped them figure out the size of the planet orbiting. They also observed the time in between transits to discover how far away the planet is from the star. This distance gives us insight about the temperature. These 2 factors means that the planet may contain water, making life quite possible. Discoveries like these led to the development of classifying exoplanets. All exoplanets are made of the same elements as planets in our solar system, but they are classified in 4 ways. The first one is Neptune-like planets. They are large and full of gases. Next are hot Jupiters or gas giant planets that orbit close to the star. Then there are super-Earths. They are smaller than the gas giants, but larger than Earth. They are primarily made of rock or icy material. The final classification is Earth analog. These planets are similar to Earth in size, composition, and distance to their parent star. Every discovery about exoplanets teaches us about how our universe works. Astrobiologists study size, composition, and location to potentially see if new habitable places exist somewhere else. So the search continues. Maybe one day we will find that planet that is suitable for life, or even maybe we'll find a planet that already has it.